The next two graphs are a little bit more complicated, but they're going to follow the same process. So to start out, we always want to start by simplifying. So we're going to take this function, now 3x, that can't be simplified anymore, but the denominator, that can be factored into x plus 2, x minus 1. And that's just going to make things a little bit easier. Now, nothing cancels out of that, so we're still kind of stuck with that function, but at least it's a start. So we are going to start with the x-intercept. Remember, x-intercept, we plug 0 in for y. Now, to solve this, we're going to multiply both sides by this denominator, okay? Both sides. Now, those are going to cancel, and this is just going to be 0. You may have seen through this process that basically when we're finding the x-intercepts, you only need to set the numerator equal to 0 because the denominator is just going to kind of cancel out of there. So we get an x-intercept at 0. Next, we're going to find a y-intercept. We find y-intercepts by plugging 0 in for x. And when we do that, we get 0 in the numerator, and it doesn't really matter what we get in the denominator, just 0. So that's our only intercept, is 0, 0. So now we're going to look at vertical asymptotes. I guess we'll put those right here. So to find the vertical asymptotes, we set our denominator equal to 0. And this time we have 2, x equals negative 2 and x equals 1. So that's what these look like. And then for horizontal asymptote, we need to look at the degrees. The numerator is degree 1, the denominator is degree 2. So thinking back to our rules from 4.1, if the degree in the numerator is less than the degree in the denominator, our horizontal asymptote is y equals 0. Now we need to make a comment about this. Vertical asymptotes we are never going to cross. Horizontal asymptotes do get crossed sometimes because remember, horizontal asymptotes are about end behavior. So our graph is going to approach 0 in its end behavior, but notice right here, it actually crosses that asymptote, and that's okay. So horizontal asymptotes might get crossed sometimes. All right, our last step is we need more points because we don't have any clue what's happening here. So one of our asymptotes is negative 2, so I want at least 2 points on the other side. So I'm going to plug in negative 4 and negative 3. I can't plug in negative 2. But I'm definitely going to plug in negative 1. I've already got 0. I may even want to plug in 1/2. And then I can't plug in 1, but it'd be a good idea to plug in maybe 2 and 3 because we need to see what's going on in this graph. So I'm going to plug in 2 and 3. Okay, so use your calculator to do this. When you're doing this in your calculator, it might be easier to go back to the original form. Just make sure you put parentheses around that entire denominator. But when you plug in negative 4, you get negative 1.2. Negative 3 is going to be negative 2.25. Negative 1 is 1.5. 1/2 is negative 1.2. 2 gives us 1.5. And plugging in 3 gives us 0.9. All right, so let's graph those. Negative 4, negative 1.2, negative 3, negative 2.25. Now, we may want to stop here and just see what's happening just on that section. So we can see that these are going to look like that. Okay, we're going to approach our asymptote, so that's pretty normal. This middle section is where stuff kind of can be funny. Negative 1, 1.5. And 1/2, negative 1.2, so right in there. So what's going to happen is, looks like this is approaching that way, and then we're going to come down here and approach that way. I'm really sorry about that squiggly line. And then we have 2, 1.5, and 3.9. So this looks like this. You can definitely check that on Desmos, but that is what we've got happening there. All right, let's check out one last graph down here in number 4. So we're going to follow the same process. We're going to start by simplifying. So this graph, the numerator is x plus 2, x minus 2, and the denominator is x minus 3, x plus 2. Now, oh, this is interesting. Do you see that the x plus 2's cancel? So that leaves us with x minus 2 over x minus 3. So that's a simpler function, which is nice. That is good news. But that also means that something weird is happening, because at x equals negative 2, at this point, negative 2, we can't plug in negative 2 because we'd still be dividing by 0. So that's not going to work. But it's not a full asymptote because it canceled out. So anytime that you have this where it cancels out, that means you have a hole in the graph. So just one little spot where it's undefined. And to find the y value, just come over here to the simplified version, plug in negative 2, and we'll find out where that hole is. It's at negative 4 over negative 5, so at 4/5. So at negative 2, 4/5, we have a hole in the graph. Okay, now that we found that out, let's go on with the rest of it. Now, everything else I'm going to do from the simplified form. There's no reason to go back to the original. So to find our x-intercepts, we're plugging in 0 for y. I'm going to multiply both sides by the denominator, which is just going to give me 0 equals x minus 2. So x equals 2. We have an asymptote, an intercept there. To find the y-intercepts, we plug in 0 for x, which is going to give us 2/3. So 0, 2/3, maybe right there. We're going to find our vertical asymptote. So we take our denominator and set it equal to 0. So we x equals 3. Remember, we don't need to set this x plus 2 equals 0. We already know it's a whole, not a full asymptote. So here's our asymptote. Horizontal asymptotes, the degree is the same on the top and bottom, so that means we're going to use our leading coefficients. So 1 divided by 1. And that's what we have going on here. So you can definitely see what's going on here. That's going down like this, and then it keeps going that way, just with that hole in it. Looks like we need a couple of points on the other side of the asymptote. So let's see, we'll plug in 4 and 5. Again, plug it into the simplified version. It's going to be a lot easier to see what's going on. So when you plug in 4, you get 2. 5 gives you 3/2. So 4, 2, 5, 1 1/2. And there's the rest of the graph.